From this chapter you're asking, Fahad? From this chapter, this is the last topic, the circuit portion. Because we are doing it in this class so that in case of current electricity, it becomes easier for us. Because we have to perform circuits and solve the circuits in case of current electricity as well. Now let's start. So in the last class, I just told you in brief how to decide whether the charge will divide or whether the voltage will divide. See, if you see any branching, any sort of branching like this, I think you didn't write it in the last class. So right now you can write it when I'll ask you. Any kind of branching that occurs means a different wire is there. Then the current divides. A different wire is there means what? New wire is there. In the same wire, same amount of charges will flow. As the branching occurs, the current divides. But the branching doesn't affect your voltage. Even if the wires are getting divided, voltage will still be the same in the wires. Take this example that I was discussing. Charge is flowing. Capacitor doesn't in it. Then charge is same. As the branching occurred, charge divided into Q1 and Q2. Now the charge getting divided equally, that depends on different condition. It doesn't mean, and it is not necessary that the charges will get divided equally. Charges can get divided in any ratio unless and until they are identical or whatever, that I'll tell you as soon as we'll keep on doing the resistors and no, not the resistors right now, capacitors we'll be dealing with. So we'll do lots of circuits because to handle it, and then resistors also we'll see the same in case of current electricity. So it's better if you pay attention to this, to the capacitors that are there, whatever capacitors are there. Just understand this, because whatever is you will be learning in this lesson, that will be same applied in case of resistors. Just the difference that will occur is if charge is flowing here, current will be flowing there. And division of voltage, capacitor, resistor, inductor, any device connected, that changes your potential difference. So like if this is a wire flowing, potential is same. In the same wire, potential is there. As the wire got divided into two parts, the potential is still same. But as we saw this capacitor came, then the potential on either sides of the plates of capacitor, that was different. And how do we get the potential difference? Potential difference is given by VA minus VB, like this. Now, series combination and parallel combination, let's start with it. But before that, I think you should write down this. Okay, let's see this also. Capacitor is here, so potential got changed. Capacitor is here, potential got changed. Branching came, potential is still the same. As again a capacitor came, potential got changed. Again a capacitor came, potential got changed. So all the potential depends on the device and the charge depends on the branching. So note these points down, then we'll do series and we'll start with series combination first. Just note this down. No, Fahad, not VR actually. This is VB. VA is potential at this side of plate and VB is potential at this side of plate. So if you want to find out the potential difference, just subtract it, VA minus VB. So done. One thing that you have to remember in case of series combination and parallel combination, that will make your work easier for calculation of the entire C equivalent, means equivalent capacitance. In case of series combination, the quantity that remains the same is charge. So remember, in series combination, charge remains the same. When is this line helpful? This knowledge is helpful when you will be getting different kinds of circuits, and in those circuits it can happen that you're not able to identify whether it is series combination, whether it is parallel combination, what kind of combination is there. So look at the charges. If you see charges are same, then you can directly say if charges are same, then the series combination exists. In case of parallel combination, potential remains the same. But parallel combination, let's do it separately. Right now, let's focus on series combination. So in series combination, remember, charge will always be the same. Yes, like charges have value is same. Then you can say 4 coulomb, so 4 coulomb everywhere. 5 coulomb, so 5 coulomb everywhere. Value is same. Magnitude basically that is same. And direction, the electric charge is a scalar quantity. It has no direction. So charge remains the same. Let's say two capacitors are connected with a cell. Now this has capacitance C1. Let's say this has capacitance C2. Let's say n number of capacitors are connected. Let's not take two only. Let's say n number of capacitors these are connected. This is Cn, mean n number of capacitors have been connected. So charges will be what? Charges across all of these will be Q only because it is in series combination. So charge remains the same. But what about potential? Potential will be different. Let's say V1 is the potential of the first capacitor. V2 is the potential of the second capacitor. Up till so many capacitors are connected, and Vn is the number of nth capacitor that is connected. And I have taken it randomly. It can be any value, 2, 3, 4, 5. Any number of capacitors can be connected in series. So quantity that remains the same is known as electric charge. Now, can anyone tell me what is the formula of charge in terms of capacitance and voltage? Anyone from the class?
Q is equal to C.
Q is equal to C. Yes. So net charge will be what? Net charge will be equal to Q is equal to CV. That is right. So what will be the net potential? Potential will be equal to V1 plus V2 up till Vn. So Q is equal to CV. So potential will be equal to what? V will be equal to Q by C. So just write it. For the first one, charge is Q. This is the net charge, Q. And what is the total capacitance? Total capacitance is C equivalent, which we are calculating, is equal to V1 is what? Charge is Q, capacitance is C1 plus V2. Charge is capital Q because charge remains the same, capacitance is C2. Up till Vn, charge remains the same, capacitance is Cn. See, Q gets cancelled from everywhere. 1 by C equivalent becomes equal to 1 by C1 plus 1 by C2 up till 1 by Cn. Up till 1 by Cn basically means if let's say there are 4 number of capacitors. So equivalent capacitance is given by 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 in this manner. So this is, and this is the derivation of it also. Derivation of the series combination and parallel combination hardly comes in exam, but it can come. Since it's very small, so in your small markers question it can come. But derivation is very, you people can easily do it. Now, if the charge is asked, total charge is asked to calculate. If total charge is asked to calculate, multiply the total capacitance by the total potential. This way you will get the total charge on it. Total potential will be given to you. Total potential is the potential at the battery, that is written capital V. C equivalent we have understood, fine. Different potentials. If different potentials are asked, no, V1, then write it as Q by C1. V2, Q by C2. Vn, Q by Cn. Charge will remain the same no matter what. Values of capacitance and potential, that will differ. So in this way you can calculate. Even if some in questions further detail is asked to calculate, you can calculate on the energies. So energy also you can write. Total energy of system is asked, then what you can do, total energy can be given by half C equivalent total potential V square. If individual energies are asked, then what you can do, U1 will be equal to half C1 V1, U2 will be equal to half C2 V2, or you can use this formula as well, Q square by 2C1, U2 is equal to Q square by 2C2. Here also you can use Q square divided by 2C equivalent. Any formula you can use. C equivalent, we are finding the formula. Yes, in for C equivalent means calculation of C equivalent. First, you have to use this formula. Calculate C equivalent. We'll do a question. I think a question. Yes. I have written this question prior. So this question we'll do. I think note down the points. Then we'll solve this. 5 farad, 10 farad connected with 10 volt. This is the simplest series circuit possible. So just quickly note it down. Then we'll move on to pattern. Before doing that, after doing that question. But remember, in series charges remain the same, because this is very easy, the circuit where series capacitors are connected in the same order. But you can get circuits where different wires are going here and there, and you're not able to identify whether it was series or parallel. So there you have to keep in mind, if you see potential is remaining the same somehow, it will simply be parallel. If charges remain the same, it will simply be series. Oh, yes, yes, Fahad, right. There is a square. Half C1 V1 square will be there. Yes, right, thanks. But it's better if we use this formula, charge 1. Try to use this because charge is same. So that most of the time helps in calculation. Because charge is given most of the time. So otherwise you have to find out potential. But whatever will suit you, answer will be the same by all of it because actually all are equal. So if you people have written this part, shall we move on to the question? All right, let's move on to the question directly. So at least C equivalent, all of you should tell me. At least C equivalent, tell me. Then just take 2 minutes. At least first part, all of you should submit. Even the second part is very easy, but at least try the first part. Then I'll discuss the rest of the parts. 2 minutes I'm giving. Whoever gets the answer, submit it in the chat box. Then we'll discuss it. Charge is not given, Fahad. That's correct. But charge you can calculate. You know the total voltage. You know the equivalent capacitance. I think, Abia, you have calculated 1 by C equivalent. What are the numbers given? 5 and 10. No. You have to tell me C equivalent, not 1 by C equivalent. Okay, let's discuss it then. For the first part, C equivalent, 1 by C equivalent is given by 1 by C1 plus 1 by C2. See, 1 by C equivalent, C1 is given 5 farad, C2 is given 10 farad. Fahad, you cannot directly add them in the denominator. All right, because denominators are different. So you have to take the LCM. So LCM will obviously be 10. So multiply and divide it by 2. That's how we take the LCM. So this becomes what? 1 by C equivalent becomes 2 plus 1 divided by 10, that is 3 by 10. Now see Abia, here your answer was right, but this is 1 by C equivalent. In the exam, you have to mention C equivalent. So always reciprocate it. C equivalent will be what? Reciprocal of it. Do not forget to reciprocate it. This much farad. So I think only Madiha gave the correct answer. Let me check Madiha's answer. Yes, Madiha, your answer is right. All right. Now, total voltage. Can total voltage anyone tell me without even calculating by just looking at this figure?
It's
Anyone?
10.
It's 10. Exactly. Who answered? It's 10. Right. Oh, okay, good. It's 10. See, total voltage is voltage that is connected at the whole circuit, voltage for the complete circuit. Individual voltages we are not aware of. Obviously, we don't know what is the voltage of 5 farad, what is the voltage of 10 farad. But total voltage is 2 volt only. That you don't even need to calculate. 10 volts, sorry. Third part says what? Third part is asking total charge stored. See, total voltage, total capacitance, so total charge you can get. Total charge will be equal to total capacitance into total voltage. Total capacitance is 10 by 3, voltage is 10, that gives 100 by 3 coulomb. Clear? This is the third part. Any part, wherever any part you are having issues, ask me, because parallel combination will be easier for you to calculate. All these parts will be there again. Then we have charge stored in each. All right. So we have to find out the charge stored in each. For calculation of charge stored in each, we have to find out the voltage stored in each. All right. So C equivalent is also given. So at least I think before we move on to fourth and fifth part, just write it down. Otherwise, it will become confusing at the end. Just write down at least this, then we'll do fourth and fifth together. So I think by now you must have written it down. Three parts done. So 3 parts are clear. Now let's do the fourth and fifth part. Fourth part was what? Charge stored in each. So can anyone tell me for the answer for the fourth part as well? Charge stored in each. Any idea? You don't again have to calculate. what happens to the charges? C1V. No, potential is different. What did I tell you? In case of series combination, this will be having V1, V2, different values. What happens to the charge? Charge remains the same. If total charge of the circuit was capital Q, across each capacitor, this capital Q only will flow. No, that's why we call it as series combination. So answer for the fourth part is easier. Q1 is equal to Q2, which is equal to actually the total charge. That is 100 by 3 coulomb, this much. Voltage across each, that is given by Q is equal to CV, V will be equal to Q by C1. So V1 will be equal to charge is 100 by 3, C1 was 5. So this becomes 20 by 3 volt. V2 will be equal to what? Q by C2. So V2 will be equal to 100 by 3 into 15. So that gives 10 by 3. Sorry, not 15, 10. Other capacitance was 10. So this becomes 10 by 3. Now you can even check 20 by 3 plus 10 by 3. That gives you complete value. V2 is equal to Q by C2. Yes, like this. Good. So note it down. Now let's move on to parallel after noting this. Parallel will be similar to it, and it will now be easier for you to understand. Just let me know when you have written these two parts. Done? All right. So I hope you have understood the series combination. Any doubts in here, just ask me. Let's move before we move on to the parallel. All right. If you have any queries, just ask me. So I think you have understood. Now in parallel combination, voltage remains the same, but charges now will be different. The reason in case of parallel combination, branching comes. And whenever there is branching, then the charge gets divided. That's why charge will be divided over here and potential will remain the same throughout. So what will be the net charge? Net charge will be equal to Q1 plus Q2 plus Q3 plus Q4 up till Qn. Q is equal to CV. So total charge will be equal to what? Total charge will be equal to total capacitance into total potential. Charge on the first one will be equal to capacitance of first, potential is the same. Q2 will be equal to C2V plus C3V up till CNV. Potential will be the same. V, all the potential gets cancelled. What's the formula that we get? The formula here we get is, the formula here we get C equivalent is equal to C1 plus C2 plus C3 up till Cn. This is the formula that you get in parallel combination. So in series combination, you have to reciprocally add it. In case of parallel combination, you have to directly algebraically add it. Now, even if total charge is asked, total charge will be equal to what? Charge, not total charge obviously. Total charge of the whole circuit can be possible. That will be given by C equivalent into V. Charge across each will be given by C1V. Like this, C2V. So for nth, it will be CN, like this. And rest of the things will be the same. So note down this part also, and then we'll do one more question. This question on parallel. Because Samya, in case of parallel combination, potential is same. So potential from all the values got cancelled since it is having the same value. Now at least tell me C equivalent. Try these parts, at least till third part you people can solve it. But first C equivalent everyone should try. Zaid, just check your answer again. It's parallel combination. The rest of your answers are right. Samia is right, Madiha is right, Fahad is right. Just check once again. Your magnitude is almost near to the answer. See how do you calculate C1 plus C2. And second part also others answer who have answered the first part. Yes, Abia, right. Abia mentioned the units as well. Yes, Samia, 10 volt is given. Yes, Abia, second answer, 10 volt, that is right. Third part, Samia, third part as well. Abia, third part. Try the third part. Yes, Madhya, right. Samia, your magnitude of charge is not right. Madhya, yours is right. Fahad is correct. Abia, yours is correct. Yes. Samia, check your calculation once again. See, C equivalent will be what? Zaid, what about you? No answers from your side. Okay, Zaid has tried the first part. See, Zaid. And Rifat, any answers from your side, Rifat? Yes, Zaid. Second answer is right. Rifat, you also tried the part. See, C equivalent is what? In case of parallel combination, C equivalent is given by directly the sum of all the capacitance that are given. So this equals to C1 plus C2. Now C1 is given as 5 farad, C2 is given as 10, so total becomes 15 farad. This will be the answer. Total voltage, like the previous case, total voltage will be what? Total voltage, this will be 10 volt. So total voltage this is 10 volts. Now total charge. Total charge is given by what? Total capacitance multiplied by total potential. So total capacitance here, total capacitance is 15, total voltage is 10. So 15 into 10 gives 150 coulombs. This is the total charge. No, Zed. See, I'll tell you. In this case, C equivalent is directly given by C1 plus C2. So that's why we are writing 5 plus 10 is equal to 15 farad. In case of series combination, here, in case of series combination, the formula was for 1 by C equivalent. So 3 by 10 that we were getting, this 3 by 10, this is equal to 1 by C equivalent. But answer wants C equivalent. That's why in case of series combination, we have reciprocated it to as to get C is equivalent by 1, that is 10 by 3. You don't have to reciprocate it everywhere. It's just that you have to find it for C equivalent. So in this case, C equivalent was given in the denominator. So as to find it in the numerator, we had to reciprocate it. Otherwise, in case of series combination, it is directly given. What were the other parts? Voltage across each. Voltage across each is also same. Voltage in case of parallel combination, this is the same. So voltages, this is given by V1 is equal to V2 is equal to 10 volt. That will be the same. Yes. 30. No, not 30. Potential is the same, no, in case of parallel combination. So potential will be the same. Then what's the next part? Charge across each. Okay. Charge across each will be given by C. Charge across each means Q1 will be given by. Okay, yes, right. So Madhya, do mention Q1 and Q2 and also write the SI units whenever you are giving the answer. Magnitude is correct. Q1 is equal to C1 into V. Similarly, Q2 is equal to C2 into V. So C1 is 5, V is 10. So that becomes 50 coulomb. C2 is 10, V is 10. That gives 100 coulomb. Now you can see total charge came out to be 150 coulomb. So 50 plus 100, that gives 150. So by this way also you can check energy in each and total energy stored. See, energy in each. U1 can be given by half C1 V square. U2 will be given by half C2 V square. Potential will be the same and capacitance will be different. So C1 is what? 5. V is, this becomes 100. So 500 by 2 gives 250 joules. This is half, C2 is 10, V square is also 10 square, that becomes 100. So 1000 by 2 gives 500 joules. Now last part says total energy. See, U1 is this, U2 is this, so total energy will be what? Total energy will simply be U1 plus U2. That becomes 250 plus 500, which gives 750 joules. This will be the final answer. Yeah, so note down all the parts, whichever part you're not able to understand, ask me. written by now? All right, now let's practice some more circuits. The basics is done. Let's just practice more circuits so that exams, different circuits will come. So let's see some more circuits. Okay, like this one. See, in this circuit, this is a series and parallel combination, both are mixed. So let me name it. Let's say this is 1, this is 2, this is 3. Rifat, can you try? I'll help you. Can you tell me if 1 and 2 are connected in series or they are connected in parallel?
Parallel.
They are connected in parallel. So whenever they are C1 and 2, these are connected in parallel. So C12 will be given how? Simply 5 plus 10, that is 15. Now this whole circuit, this has become 15 farad right now. 15 microfarad, not farad, 15 microfarad. Now see, this 10 farad, 10 microfarad is now connected with 15 microfarad. This has been reduced to 15 farad. Zaid, now can you tell me which combination is this? Series. So this was 3, this was 1, 2. So C12 and C3, these are connected in series. So 1 by C equivalent will be given by 1 by 10 plus 1 by 15 microfarad. At the end, we'll put microfarad. So C equivalent will be what? This will become equal to 15 into 10 divided by 15 plus 10. That becomes what? This becomes 150 divided by 15 plus 10. This becomes 25. Clear? So that becomes, I think, 6 microfarad. This will be the final answer. Yes, 6 is the answer. 1 by 6 was 1 by C equivalent, 6 is the answer. Good. All right, so this way you have to do these circuits. Write down this circuit as well. Then we'll do one more circuit, this one. Yes, Wafia, how are you?
Fine, ma'am.
All right, Wafia. So we have almost reached the end of this lesson. So do take the recordings and see the videos on this circuits. We are just doing the series and parallel combination. So basics we have understood. We are just solving more of the circuits.
Okay, ma'am.
Ma'am, is 1 microfarad 10 raised to minus 6 farad?
Yes, yes, 10 to the power minus 6 farad. So if everything is given in terms of microfarad, you can write the final answer in terms of microfarad. But if the answer is given differently and different values are given, picofarad, microfarad, nanofarad, or only farad is given, then convert. But right now in these kinds of questions, you can leave the answer in terms of microfarad. Okay, one more circuit. So a hint I'll give you, just take 2 minutes, then I'll discuss it. Start from here, look at them, then reduce it, then look at it, then reduce it, then see, then again reduce it. Keep on searching for series and parallel combinations. Last 2 minutes, then after 2 minutes, we'll discuss it. See, to begin with, first start with these. These are appearing to be parallel combination. Obviously, with branching, you can see they are connected with the help of branch. After 1 and 2, no, 3, with 3. After 1 and 2, it will be 3. I'll show you. This is what? This is 1 and 2. So equivalent will be what? These are connected in parallel, no? So 1 and 2 are connected in parallel. So equivalent C12 becomes directly C plus C. That gives 2C. Now, how does your circuit look like? Now your circuit looks like these are there connected. C5 is also there. 5, 4, 6 are there. 3 is also there, but now 1 and 2 have been reduced into 1, 2. So C12 is there, and this is third one with all the values C. Now we have to reduce it further. So see this value. Both of it. Can anyone tell me how these are connected? 3 and 1, 2. Anyone? See, a single wire is going. Between
It's in
C3,
series.
it's in series, Madhya, right? They are connected in series. See, this simple straight wire is there, and capacitor doesn't block your potential. So potential will be different because of capacitors. Charge will remain the same as it is a single wire going on. So these are connected in series. So C1, 2, and 3, these are connected in series. So equivalent capacitance C1, 2, 3. This will be given by C1, 2 plus 1 by C. C3 is what? C3 is C. And C12 is what? C12 is 2C. So C123 is equal to 1 by 2C plus 1 by C. So C123 becomes 2C square divided by 3C. That gives 2C divided by 3, this much capacitance. All right, so we have reduced this also. Now how the circuit will look like. See, these are connected. But instead of C3 also, we have C1, 2, 3 right now. This is 4, this is 5, this is 6. This was A point, this was B point. Now look at this. How are 4 and C1, 2, 3 connected? C1, 2, 3 and C4 connected.
Parallel.
Yes, Samia, they are connected. These are connected in parallel combination. No, Fahad. See, wiring is occurring. Remember, I just turn the figure. Turn the figure like this. Then you will be able to recall the parallel combination. Branching is occurring. No, charges get divided here. Potential will be the same. So this is in parallel. So C1, 2, 3, 4 will be what? 2C by 3 plus this C. That becomes 3C. That becomes 5C divided by 3. This is the circuit C1, 2, 3, 4. Now how our circuit will look like if we reduce it further. See, this is 5, this was C1, 2, 3, 4, this is 6. This is actually the final point we had where we had to reach. This is C, and this is 5C by 3. Now can you tell how all three are connected? Series, yes, Samia. All these three, these are connected in series. So C5, C6 along with C1, 2, 3, 4, these are connected in series. So ultimately we have to add them, reciprocate. So 1 by C equivalent is what? 1 by C plus 1 by C plus 3 by 5C. So LCM will obviously be 5C. So 5C is the LCM. So this becomes 5C. Here you have 3 plus 10, that is 13. So C equivalent will, see, this is 1 by C equivalent. So C equivalent becomes 5C divided by 13. This much, only this much, because no unit was given. So this much capacitance, this much fat. This is the C equivalent. This is how you have to solve long circuits. If long circuits are given, keep on reducing them, draw the figures again. This was the initial circuit. Ultimately, it was left till here. So just keep on drawing the circuits again. Clear? So note this down question as well. So we'll be doing more circuits when we'll reach current electricity. There we'll see lots of circuits there also with resistors placed. So concept will be the same. But one thing that is unique in case of capacitance is this. Yes, problems involving plates. This you will see and you will find it in only case of capacitance. Remember how to do, if you see such kinds of plates, how to solve this. Let's say this is A point, this is P point, and you have to find out the equivalent capacitance. So how to find it right now, since nothing is mentioned? First, connect it to a positively charged terminal and a negatively charged terminal. Understand the method. This is unique for capacitance. Now what will happen? The plate that is connected to the positive end, that will develop positive charge like this, and the plate that is connected to the negative end, that will develop negative charge like this. Now what did I tell you when we were discussing capacitors? In case of capacitors, whenever you study how to construct a capacitor, you have two oppositely charged plates. Oppositely charged, it means, let's talk about the number of plates that are here. This is first plate, this is second plate, this is the third plate, this is the fourth plate, this is the fifth plate, this is the sixth plate, this is the seventh plate, this is the eighth plate. All right, all the plates we have mentioned. Now look at it. This positive plate is in contact with nothing, so it won't make a capacitor. This positive plate is in contact with this negative plate. So positive second plate in contact with third negative plate. If let's say separation is D, this forms a capacitor. Similarly, look at plate number 4, plate number 5, negative plate connected to the positive plate. This is what? This separation, let's say this separation is D, another capacitor has been formed. This is positively charged plate, this is negatively charged plate. That becomes, yes, 6 and 7 are connected there. So this becomes D. So 3 capacitors are there. Who can tell the formula for parallel plate capacitors when they are kept in air? Anyone who remembers the formula right now? When the medium is completely filled with air, we did 4 cases. Remember on the extra class that we had on
It will
Tuesday?
be Q by V.
Not Q by V. Q by V is the general formula for capacitance. Fahad, you are right. Any other one? Samia?
Epsilon naught A upon D.
Epsilon naught A by D. Madhya, that is the general formula. That is valid for everywhere. But specifically for air, we have that. What Samia and Fahad are saying.
Okay, ma'am.
Okay, epsilon naught A by D. So in this question, no, wherever you get these kinds of question, how many parallel plates have been made? 3 capacitors have been constructed. So equivalent capacitance simply becomes 3 times epsilon naught A by D. This is how we write it. Let's do one more example. Let's take, I think one more example we can. Okay, see this. Now the construction, look at the construction. This is how the construction is done. So if you join it to a positive terminal of the battery and you join this end, this second end, to the negative terminal of the battery. So what will happen? The plate connected to the positive one, this will develop positive charge, and the plate connected to the negative one, this develops negative charge. Now let's see, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. All the 8 plate I have named. Look at plate number 2 and 3. Do you think they are forming a capacitor? This. Yes or no? Yes? This is a capacitor, no? Positive plate, negative plate. Yes, Zed, it is a capacitor. Yes, Vakya, it forms a capacitor. Let's say separation is D. What about 4 and 5? 4 and 5 do not form. Reason? Both are negatively charged. So how can you have a capacitor here? And what did you people answer? 6 and 7, Fahad. Right. 5 and 6, no, Zaid. 6 and 7, no. 5 is this. Yes, 6 and 7. Yes, 6 and 7. Right. All of you are right. This forms a capacitor. This is negatively charged. And else you don't have plate. So equivalent capacitance will be what? 2 epsilon naught A by. Simple, easy to calculate. This doesn't involve much calculation. All right, so note down both the parts. This comes. This is unique for capacitance. See, one last case is left, which is unique for capacitance. That also let's discuss. So your chapter has almost ended. Let's just discuss that. This case can come. See, if a dielectric slab, you can get dielectric slabs combination. Remember, whenever you see area getting divided, it is parallel combination. All right, like in this case, and distance, if the distance divides, or if distance is divided, it is series. Now I'll explain what is meant by this. This is the last case. Maximum your questions can lead to this case. Otherwise, not even these cases are asked. But yeah, in your entrances, these cases are obviously asked for your competitive exams like NEET, JEE and all. But for your board exams, this can come. This can come for in all the board exams. It comes. But this combination of capacitor, series and parallel, this is asked in your exam. So you have to keep on reducing the circuits. But if you see a dielectric slab, this case, area getting divided, clearly understand if area is getting divided, then obviously it is parallel combination. Now parallel combination means what? It is actually like this. So parallel combination, in parallel combination, C equivalent is given by C1 plus C2. And if a dielectric slab is introduced, what does the formula of capacitance change to? Dielectric constant is given. Let's say K is the dielectric constant. So what does the formula of capacitance become? Yes, Fahad. Fahad is right. Anyone else? No one. People were there in the classes, no? Look into your notes if you're not able to recall it. Epsilon naught A by D was for air. Dielectric slab, it will be K epsilon naught A by D. Only Fahad had answered. It becomes K times multiplying it. So C equivalent will be what? For this, K becomes K1, epsilon naught. A becomes A by 2 since area is divided. A by K C naught. Yes, C naught. And C naught is epsilon A by D. So K epsilon naught A divided by D plus K2 epsilon naught A by 2 since area is getting divided by D. This is your equivalent capacitance. If you wish, you can solve it further. Take epsilon naught A by 2D common. It will be K1 plus K2. This one more example I'll tell you. One more example, we'll do this. Distance is getting divided means separation between the plates if it is getting divided like this. See, now the area is same, but now the plates are getting divided. The distance between the plates, which was initially D, now it is getting divided. So this shows that it is series combination. And in series combination, you have 1 by C equivalent equal to 1 by C1 plus C2. So 1 by C equivalent will be what? See, C1 will be equal to K epsilon naught A divided by D. D is D by 2. So 2 will go up. Similarly, C2. C2 is what? Epsilon naught K2 epsilon naught A by D and 2 will go up. So C equivalent becomes D by 2 K1 epsilon naught A plus D by 2 K2 epsilon naught E. For solving this, it's better. I would suggest you to take common first. If you take out common, then your solving part becomes easier. So if we take out common from here, 1 by C equivalent, D by 2 epsilon naught A can be taken common. What will be left? 1 by K1 plus 1 by K2 will be left. So C, or you can solve this further. 1 by C equivalent, this will be equal to D by 2 epsilon naught A, K2 plus K1 divided by K1, K2 on taking the LCM. So what will be your final answer? Final answer will be C equivalent will be 2 epsilon naught A by D, K1, K2 by K1 plus K2. This will be the final answer. We did reciprocal right now. Right now we did. This is 1 by C equivalent. Now we did. For the final answer C equivalent, we did it. Yeah, so this can also come in your examination. So last case was there. Note down these two cases as well. And do write it down. Area is getting divided parallel, distance getting divided series. So quickly, hurry up. Just note it down. Copy it down quickly. And if any doubts are there, ask. So 3 days you have no classes in any ways. From Tuesday, we'll be having the regular classes. 3 days are off. So if you people take other subjects which are on the weekends, or for Friday is off in any ways. Saturday, Sunday is also off. This text done when you copy it down. Yes. First one was in parallel. Second one is series because area was getting divided no in the first one. That's why it was in parallel. And distance is getting divided in second one, so it is in series. So Samia are done, Rifat and Madiha are done. Abia is also done. Who all are left? Wafia, Fahad and Zaid. Done? All right. All right. Okay, fine. So class, this ends your lesson 2. Then we'll directly start with current electricity. Fine. So take care. Let's meet in the next class. Okay, you can log out. Okay, Allah Hafiz. Bye.